All right, here's our periodic table again, and we've added a bit more detail. Every column has a classification we can give to it, but still remember that the left side of the periodic table is our metals, the right side is our nonmetals, and it's kind of this staircase that draws a diagonal line between aluminum and tennessine. So, sort of on the right side that divides these two areas. It may seem, therefore, like there's a lot more metals that are going to come up, but the nonmetals are ones that we see over and over again and are really ones we're going to be familiar with a lot. So a few properties to get things going, and again, this really applies to elements. So when each of these is all by itself. Metals tend to be solid at room temperature, they're shiny or metallic, good conductors, and these are ones that we end up knowing pretty well, good properties of metals. Nonmetals are a variety of forms at room temperature. They're often not having the properties we would associate with metals, very much gases a lot of the times, and they are, ones that we really see quite a bit. Carbon, nitrogen, oxygen. These components take up a wide range of different biomolecules, and in the elemental form, they are not really like metals at all. And metalloids, again, this isn't really a big deal. They're kind of looking like metals, but behave more like nonmetals. These are really broad distinctions in the periodic table and are just getting us started with where things might be on this table. As far as what our bodies are made up of, again, we talked about really common things that we see over and over again: carbon, oxygen, hydrogen. This is by mass, and the giant amount that's devoted to oxygen is because our bodies are mostly what, right? And if you said water, that's great. And looking a little bit ahead, we're going to talk a lot about water. H2O is its formula. Hydrogens, even though there's two of them, are a lot smaller than the oxygens, and so most of that water by mass is oxygen, mostly oxygen. Of the rest of the non-water stuff, it's mostly structured based on carbon. These commas here are European-styled commas, so it should be periods 3.5, 3.5%, 9.5%, etc. But carbon-based life forms, that's what we are. That's what life is constructed of. It's that skeleton that makes up what our bodies are made of, the non-watery stuff. Then hydrogen from water, some nitrogen, some other chemical elements. This is what we are made of. 6 major elements. Here they are again, making up the majority of our biology, and we're going to learn more about them coming up. This is not to say that this is mostly elemental oxygen, right? We look at oxygen, and we've already talked how oxygen can take multiple forms. Oxygen, the gas we breathe, O2, and then there's water, which has oxygen as a part of it. This is oxygen behaving in both of these different species, but they are two different things: water or the oxygen that we breathe. The oxygen that we breathe, that's pure oxygen. That's considered the element. When we combine 2 hydrogens and 1 oxygen, we get the molecule water. Still though, the atoms of oxygen, the element of oxygen, appears in multiple places, and the same goes for the rest of these. Small but essential amounts of other elements, these exist in our bodies as well. And again, as you move forward as a healthcare practitioner, we may say, oh, your magnesium levels are looking a little bit low, or you have to eat more potassium or something along these lines. While these are small amounts in our overall body, taking a small amount or having a level that's not where it's supposed to be can really affect someone's quality of life, and identifying that it's this specific thing that does these specific things, and if we add in that specific thing, it can change someone's outcome. That can really be helpful to a patient's well-being, and something that may be a theme as you move forward in healthcare. Same with these, right? Very small amounts still play important roles. The chemicals that appear on the periodic table, many of them will be referred to in healthcare, biology, and all matter appears somewhere on the periodic table. Our phones contain so many more, right? Lots of these are metals, really a wide variety of things that make up the intricacies of the phone. This is not to say that a phone is more complicated than the human body. It's just got more different stuff. It's really kind of amazing how much the body has been able to do with such a small, relatively speaking, number of elements. And while that's not exactly what we're going to be looking at in this part of the course, it will surely be for the second half, where we really appreciate why carbon, oxygen, nitrogen, hydrogen are able to make such a huge range of complexity, even though it's just those few pieces that make up most of our body. To wrap things up, each element has a unique chemical symbol, one letter in uppercase, two letters, first uppercase, second lowercase, and this is how we begin to refer to compounds like water, H2O. H is hydrogen, 2 means 2, O is oxygen, and so on, right? A lot of times these aren't exactly the letter that the element starts with. They can be based on Latin names. Knowing the unique chemical symbol isn't something that you need to memorize, but being able to search through the periodic table to note that there's a name and a chemical symbol will be easier if you begin to kind of commit the most common ones to your memory.